A toy is in the form of a cone mounted on a hemisphere of the same diameter. The diameter of the base and height of the cone are 6 centimeters and 4 centimeters respectively. Determine the surface area of the toy. Use pi is 3.14. So here, cone is mounted on a hemisphere. So, hemisphere on the top of the cone is mounted of diameter 6. Diameter is 6 centimeters. So, radius is 3 centimeters. And height of the cone is 4 centimeters. Height is 4. See, we need to find the surface area of the toy. Surface area of the toy. So here see, surface area of the toy or total surface area of the toy if they'll tell. You need to be careful here because we need to find only the area which is visible. See, this one which is curved surface area of cone, this one, and this one is curved surface area of hemisphere. As it is a toy, you cannot take the base of the cone or top of the sphere. So curved surface area of cone plus curved surface area of hemisphere. So curved surface area of cone plus curved surface area of hemisphere. Now curved surface area of cone is pi r L and curved surface area of hemisphere is 2 pi r square. Now if you'll see in these problems, in class 10 problems, so what do you do? Don't do separately. Just my advice is take common and try to calculate. Pi r if you'll take common, L plus 2r. Now here in the problem, L is slant height. We need to find slant height. So if I'll apply Pythagoras theorem for triangle AOB, I'll get AB square equals AO square plus OB square. So AB square is 4 square plus 3 square. 4 square is 16 plus 9, which is 25. So AB is root 25, which is nothing but 5. AB square is 25, so AB is root 25, which is nothing but 5 centimeters. Now if I'll substitute the values, pi is 3.14, radius is 3, slant height is 5 plus 2 times radius, which is 3. So 3.14 into 3 into 5 plus 6. Now if I'll multiply this 3.14 into 3, 3 times 3 9, so 14 times 3 42. So 3.14 into 3, you'll get 9.42 into 5 plus 6 is 11. So 9.42 if you'll multiply with 11, you'll get 2 plus 4 6, 4 plus 6 13. So 103.62 centimeter square. So area is 103.62 centimeter square. Surface area of the toy is 103.62 centimeters square. A solid is in the form of a right circular cylinder with hemisphere at one end and cone at the other end. The radius of the common base is 8 centimeters and the height of the cylinder and conical portion are 10 centimeter and 6 centimeters respectively. Find the total surface area of the solid. So here, see, hemisphere cylinder, we have a cylinder with, I'll draw here. Cylinder with hemisphere at one end and cone at the other end. The diameter, the radius of the common base. So radius for cylinder, cone, and what we'll call like hemisphere, all the radius is 8 centimeters. Height of the cylinder is 10 centimeters and height of the cone is 6 centimeters. We need to find the total surface area of the solid. Here again the same like the previous one. See, total surface area of the solid is curved surface area of cone plus curved surface area of cylinder plus curved surface area of hemisphere. See, here the word total is given. It doesn't mean we need to find total surface area of all. See, the area which is visible. See, this is the solid, so only this curved surface area of cone is visible, curved surface area of cylinder, and curved surface area of hemisphere. Now here, if I write the formulas for all, like curved surface area of cone is pi r L, curved surface area of cylinder is 2 pi r h, and the curved surface area of hemisphere is 2 pi r square. So again I'm telling here, you should try to take maximum common, then try to simplify. The problem will be like easy. Pi r, if I'll take common, L plus 2h plus 2r. Now here in this again we don't have the value of L, so I'll apply Pythagoras theorem for triangle AOB. So I'll get the value like AB square equals AO square plus OB square. AO is 6 square, OB is 8, 6 square is 36 plus 64. So AB square is 100, AB is root 100, which is nothing but 10. So slant height is 10. Now if I'll substitute the values, pi, the total 3.14, radius is 8, slant height is 10, 2 times h, height of the cylinder is 10, and 2 times radius, that is 2 times 8, 60. 3.14 into 8, 10 plus 20 plus 16. Now 3.14 into 8, here 10 plus 20, 30, 30 plus 16, 46. Now if you multiply all these values, you'll get like 3.14 into 8, 25.12, and again then multiply with 46. See, you can multiply 2512 into 46. You'll get this value, 1,15,552. So if you keep the decimal, it is like 1,155.52 centimeter square. So 1,155.52 centimeter square. In textbook, the answer is 1156.57. This value if you'll get if you'll use pi as 22 by 7. But here clearly they mention in the question that use pi as 3.14. So if you use 3.14, we'll get 1155.52 centimeter square. A medicine capsule is in the shape of a cylinder with two hemispheres struck to each of its ends. The length of the capsule is 14 millimeter and the thickness is 5 millimeter. Find its surface area. So here I'll redraw this one. I'll draw again. Cylinder with two hemisphere ends. So here the total length is 14 millimeters and radius is 2.5. So see, this also will be 2.5 because radius, this also 2.5. So height of the cylinder will be 9 millimeter because from 14, if we'll take out 2.5 and 2.5, 14 minus 5, which is 9 millimeters. So height of the cylinder is 9 millimeters. Because here, if you'll see the hemisphere, this is radius, this also radius, this also radius. So this also will be the radius. So radius is here 2.5. So 2.5 and 2.5 will take out, we'll get the height of the cylinder. Now surface area of the capsule. Surface area is curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of again hemisphere. So now if I'll write the formulas, curved surface area of hemisphere is 2 pi r square and curved surface area of cylinder is 2 pi rh. Curved surface area of hemisphere is 2 pi r square. So here maximum if you'll try to take common 2 pi r, I'll try to take 2 pi r common. So here r is r plus here h and here again r. So now if you'll calculate 2 times pi is 22 by 7. Radius is 2.5, which is nothing but you can write as 5 by 2. Here 2.5 plus h 9 plus again 2.5. So here 2 into 22 by 7 into 5, 2.5 plus 9 plus 2.5 is 14, 5 by 2. 7 times 1, 7 times 2, and here 2 and 2 will get cancelled. So 2 into 22 into 5. So clearly 5 into 2, 10. So we are getting here clearly 220 millimeter square. 220 millimeter square. So clearly we'll get 220 millimeter square. So surface area of the capsule is 220 millimeter square. Here in textbook it is given that answer is 219.8 millimeter square. This value you will get if you use pi as 3.14, but here I took pi is 22 by 7 as it is not mentioned in the question, so I took 22 by 7, so the answer is 220 millimeter square. Two cubes each of volume 64 centimeter cube are joined end to end together. Find the surface area of the resulting cuboid. So here two cubes each of volume 64 centimeter cube. So volume of a cube is 64. Volume of a cube is 64 centimeter cube. So volume of a cube formula is a cube is 64. So a cube I can write as 4 cube. So the value of a is 4 centimeters. Now two cubes are joined end to end So now the edge of one cube this will be in the form of a cuboid. So the length of the cuboid is 4 plus 4, which is nothing but 8 centimeters. Breadth will be 4 centimeters and height 4 centimeters. So here we need to find total surface area of the resulting cuboid, because see, when two cubes are joined, we'll get a cuboid, so whose length is 8, breadth is 4 and height is 4. So they're saying surface area of cuboid. So total surface area of cuboid, that is 2 into LB plus BH plus HL. So 2 times length is 8, breadth is 4, 4 into 4, height is 4, length is 8. 2 times 8 into 4, 32, 4 into 4, 16, 4 into 8, 32. 32, 32, 64, 70, 80. So it is 160 centimeter square. Or you can do this in another form also. See, surface area of cuboid. Surface area of cuboid. See, it is a cube. It has like 6 faces. So total surface area of cube is 6a square. This cube also 6a square. But when two cubes are attached here, are joined end to end, so what is, see, for the left side, for this one which I am showing here, for this only 5 faces are visible. For this right side one also 5 faces are visible. So surface area will be 5 plus 5 here, 10a square, and edge is 4. So 10 into 4 square, 4 square is 16. So directly you can write 160 centimeter square. A water tank consists of a circular cylinder with a hemisphere on either end. If the external diameter of the cylinder be 1.4 meters and its length is 8 meters. So external diameter of cylinder is given and its length is 8 meters. So cylinder height is given. Then find the cost of painting it on outside at of rupees 20 per meter square. Fine. So here a water tank is in the shape of cylinder with hemispheres on either end. So here one hemisphere, one more is here. So radius, diameter is 1.4. So radius is 0.7, half of diameter, and height of the cylinder is 8. Find the cost of painting it on outside. So first I'll find surface area of the tank. Surface area of tank, that is nothing but curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of hemisphere. So now if I'll substitute the formulas, 2 pi r square plus 2 pi rh plus 2 pi r square. So 2 pi r, again I'll try to take common 2 pi r plus h plus r. So now here 2 into pi value is 22 by 7, radius is 0.7, 0.7, height is 8 plus 0.7. So 2 into 22 by 7 into 7 by 10, 0.7 plus 0.7, 0.7 plus 0.7, 1.4, 1.4 plus 8 is 9.4. So now here 7 and 7 cancel. 2 times 1, 2 times 5. So 22 by 5 into 9.4. Or you can write 22 by 5 into 94 by, you can write 94 by 10. And here you can cancel if you want 2 times 11, 2 times 5. So here we'll get 11 times 94. 11 times 94 is 1034 by 5 into 5, 25. This is meter square. Now cost of painting. Here cost of painting. So total area, that is 1034 by 25 times 20, because per meter square 20 rupees. So if we'll cancel this, 5 times 5, 5 times 4. So we'll get 1034 into 4 by 5. 1034 into 4, if we'll do it, we'll get 4136 by 5. So if we'll divide this value by 5, you'll get clearly 827.2 rupees. So rupees, the cost of painting is rupees 827.2, 20 paisa. A sphere, a cylinder and cone have the same radius and same height. Find the ratio of their volumes. So here sphere, cylinder and cone. So same radius and same height. Same height is here like that. So what they want to say is, here if we'll take the diameter, this is diameter of sphere. So this is R and R. So height and height of cone. So height I can write as 2R. Height of cone and height of cylinder I can write as 2R. So volume, ratio of the volume. So volume of sphere, volume of cylinder, volume of cylinder and volume of cone. Volume of sphere is 4 by 3 pi r cube. This is pi r square h. And volume of cone is 1 by 3 pi r square h. 4 by 3 pi r cube. Pi r square in place of h I'll write 2r. 1 by 3 pi r square in place of h 2r. So 4 by 3 pi r cube, 2 pi r cube, r square into r. 1 by 3 pi 2 pi, sorry, 1 into 2 you can write 2. 2 by 3, 2 by 3 pi r cube. So now here it is 2 by 1. So what I'll do is I'll write as, see first one. So here I'll write 4 by 3 pi r cube. Here 2 is there, so I'll multiply and divide with 3. So 6 pi r cube by 3, because 3 times 1, 3 times 2, and 2 by 3 pi r cube. So here 3, 3 and 3 cancel, pi r cube and pi r cube. So you are left with like 4 is to 6 is to 2. So if you'll cancel with 2 table, 2 is to 3 is to 1. 2 times 2, 2 times 3, 2 times 1. So the ratio of their volumes is 2 is to 3 is to 1. A hemisphere is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to the side of the cube. Determine the total surface area of the remaining solid. So here, from one face of a cube, see if we'll draw a cube here this way. From one face, a hemisphere is cut from one of the face. So if we'll take the top face here, hemisphere has been cut. So determine the surface area, total surface area of the solid. So total surface area of the solid. So here what I'll do, I'll find the total surface area of a cube, because all 6 faces I'll take. Then hemisphere, this part. See, otherwise first what I'll do, I'll total surface area of a cube. Then see, when I'll take all 6 faces, but here in the top face a circle has been cut, like hemisphere has been cut, so this circle part is missing here, this one. So what I'll do, I'll subtract area of circle plus, and see here circle at the top is missing. See, because if you'll see the top face, it will be like this. Top view, it has been cut. The borders are like left, these are left corners. So that's why I took all the 6 faces, and from that I subtracted the circle. So now plus hemisphere, see this is visible, this part. So curved surface area of hemisphere. So total surface area of a cube is 6a square minus pi r square plus 2 pi r square. So 6a square minus pi r square plus 2 pi r square is pi r square. Now if I'll consider, it's not given anything, so but if I'll consider the edge as a, then diameter will be a, radius will be half of diameter, radius will be a by 2. So 6a square plus pi a by 2 whole square. So 6a square plus pi a square by 4. So if we'll take a square common, 6 plus pi by 4. If we'll take it as centimeters, so total surface area is 6a square into 6 plus pi by 4 centimeter square. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. So here 2 hemispheres has been scooped out. If the height of the cylinder is 10 centimeters and its radius is 3.5, height is 10 centimeters and radius is 3.5 centimeters, find the total surface area of the article. So here total surface area of the article, total surface area is curved surface area of cylinder plus curved surface area of hemisphere and again curved surface area of hemisphere. Because what all is visible, see here this curved surface area is visible, here this part is visible, so and here this also is visible, so this all we can find. So now if I'll substitute the formulas, curved surface area of cylinder is 2 pi RH, curved surface area of hemisphere is 2 pi r square, curved surface area of hemisphere again 2 pi r square. So if we'll take 2 pi r common, h plus r 2 into 22 by 7. See, radius clearly it is 3.5. H is 10 centimeters. 10 plus 3.5 plus 3.5. So 2 into 22 by 7, 3.5 if we'll write 35 by 10 into 17. 3.5 is 7 plus 10, 17. 7 times 1, 7 times 5. 5 times 1, 5 times 2. 2 and 2. So 22 into 17. So 22 into 17. See, 17 times 2, 34. So 34, 3 plus 4, 7. So it is 374 centimeter square. So total surface area of the article is 374 centimeter square.